In this video we're going to be talking about membranes, and we're doing this as part of the connective tissue session. And the reason for that is because membranes are formed of a collection of epithelial tissue and supportive connective tissue. So you have mucosa, which is the epithelial tissue that lies on the top, and then you have a submucosa, which is the connective tissue that lies underneath. So it is a collection of both epithelium and connective tissue, and they rely on each other. The epithelial tissue is performing some kind of usually secretory function. And as we've spoken about in your previous learning already in this section, epithelium itself has no blood supply. So it relies on the connective tissue underneath to provide it with its nourishment. Now, if the epithelium is not performing any kind of function other than protection, then it doesn't particularly need a blood supply. However, if it's producing something, so producing some kind of secretion, then it does need nourishment. And that's why the submucosa, or the connective tissue that forms part of a membrane, is so important, because it provides that nourishment from the blood supply that the epithelium can't get itself. And you'll find membranes of one kind or another lining almost all internal structures and cavities. And we also have one particular type of membrane that lines the external surfaces of our body. So there's 4 types of membrane, and those 4 types are cutaneous, mucous, serous, and synovial. So first of all, we're just going to start with cutaneous. And some of you are probably aware of the term cutaneous or subcutaneous perhaps. All cutaneous membrane is your skin. So the skin that lines the entire external surface of our body and extends into the very opening of some of the orifices as well. For example, your ear, the very opening of the external auditory meatus, which is the hole into your ear prior to the eardrum, that's a cutaneous membrane, for example. Mostly cutaneous membrane is your skin on the outside. You could argue it has a secretory function because of sweat. However, the sweat is actually coming from connective tissue lying underneath the cutaneous membrane. So cutaneous membrane is not a secretory membrane, it's there for protection. It's keratinized, stratified epithelium, so a compound or stratified epithelium, keratinized for protection on the surface. The skin starts off as tall columnar cells at the basement membrane and works up, gets smaller and smaller towards the surface where the squamous cells shed off. We all know that our skin does that. You get dry skin, it sheds, that type of thing. So it's quite straightforward. It's basically just your keratinized stratified epithelium on the surface with a subcutaneous level, so that's the connective tissue underneath. And you might have heard the term subcutaneous with certain medicines that are injected. For example, diabetics would inject their insulin subcutaneous. So that just means under the skin. So that's the first membrane. It's the biggest, it's the most predominant in all of our body. Sometimes the cutaneous membrane is referred to as an organ, and the biggest organ in our body. So it's quite straightforward, cutaneous. Moving on then to talk about mucous membrane, and I've just noticed a little spelling mistake, so let me just correct that for us. Mucous membrane. Mucous membranes, also sometimes referred to as mucosa, and we find mucous membranes throughout our body, and they are particularly relevant to us and what we do because the entirety of the oral cavity is lined with a mucous membrane. So what we're looking at here is a histological slide of mucous membrane. We can see we have, if we look at the code, the key for the diagram here, the stratified squamous epithelium on the top, so it's our epithelial layer. We've got an area directly underneath that, known as the lamina propria, and then we have the submucosa. And right down the bottom here, we've got bone. So your lamina propria and the submucosa are the connective tissue associated with the epithelium that forms mucous membranes. So just like in cutaneous membrane it was subcutaneous, in mucous membranes it's submucosa. And the purpose of mucous membranes is to provide a moist, slippery surface. So we find it in our mouth, and continuing on from there all the way through the alimentary canal. So the alimentary canal, also known as the gastrointestinal tract, the tube that goes from our mouth all the way through to our anus. It's all lined with a mucous membrane. And also in our genitourinary tracts, so your urinary tracts, urethra, that kind of stuff. Anything that needs to be wet and slippery. And the reason why it needs to be wet and slippery is obviously to allow material to pass along it. So all these areas that I mentioned there, the alimentary canal, the genitourinary tract, and also the respiratory tract as well, things need to pass along those surfaces. If they were dry, then things would get stuck. If any of you have ever woken up after perhaps a bit of a heavy night and you've got a really, really dry mouth, the last thing you want to do is try and eat something because you know you're not going to be able to swallow it. The first thing you do is you want some water to lubricate it first, and that's the purpose of the mucous membrane, for propulsion. It also, however, has a protective function. So rather than just having the epithelial layer open to the environment, there's this thick mucus layer sat on top of it. So it provides a sort of barrier. And also, if things are moving smoothly along it, you're not going to get friction, which would damage the underneath layer. Mucous membranes tend to be non-keratinized, but not always, as we're going to come on to talk about. So in order for the mucous membranes to produce this lubricative material, they need to have cells within the epithelial layer that are producing that fluid. So in mucous membranes, we have what's known as goblet cells, which is what is on this slide here. So goblet cells are specialist epithelial cells which produce and secrete the mucus. So the mucus collects in these cells, which get bigger and bigger and bigger as the mucus is produced. And then once they've reached their maximum capacity, the cell will burst. So it's going to die and burst and release its contents into the cavity, whether that be the oral cavity, the GI tract, whatever it is. So we can see from this diagram here, diagram A, that we've got two things going on. We've got a goblet cell here which has already burst and released its contents, and we've got one here that's in the process of doing that. And from a histological slide level, I think this is a really good way of demonstrating. You can see all the little pink droplets, the mucus within the cell. So it's a big, huge cell in comparison to the rest of the cells in the area. The goblet cells are much, much bigger, and they produce a lot of mucus per cell in comparison to the size of the cells. So the goblet cells are really, really vital in helping the mucous membrane perform its function. Otherwise, this would just be, say, a cutaneous membrane. It would just be a protective layer. But rather than just that, it's also a secretory layer. And like I said previously, the importance of the connective tissue underneath is that it provides enough nourishment. And you're obviously aware that producing all this mucus requires quite a lot of energy from the cells. If we go back and think about what the organelles within the cells do, the mitochondria within the cell are going to need to produce a lot of ATP in order for the cell to perform its function of producing mucus. And in order for the mitochondria to produce the ATP, it obviously needs the glucose and the oxygen. But the epithelial layer has no blood supply with which to transport the oxygen and the glucose. However, the submucosa, the connective tissue underneath, is rich in blood supply. That's why if you bite your cheek, it tends to bleed a lot, because you've gone through that epithelial layer into the submucosa, or the connective tissue, and you get a lot of bleeding from that because it's got a rich blood supply. So in terms of the mouth, the oral cavity is lined with mucous membrane, and it's what we call the oral mucosa. It is in general a stratified squamous epithelium, non-keratinized. However, there are some keratinized areas in those parts that are exposed to friction or masticatory forces. So, for example, the tissue directly surrounding the teeth, we refer to it as the attached gingivae, that is keratinized. The roof of the mouth, so the hard palate, also keratinized, because it's potentially exposed to hot things, cold things, jaggy, sharp things. In the rest of the mouth, so the floor of the mouth, the buccal mucosa, so the lining of the cheeks, the soft palate, the pharynx, the back of the throat, it's a non-keratinized stratified squamous epithelium. But it's all oral mucosa. In the areas where we've got keratinized, we refer to that as masticatory mucosa, for the reasons we just spoke about. And in the areas where it's non-keratinized, we refer to that as lining mucosa. So lining mucosa in the cheeks, the floor of the mouth, soft palate, masticatory mucosa surrounding the teeth, and on the hard palate. And we also have a specialised mucous membrane in our mouth, which is the dorsal surface of the tongue, so that's the top of the tongue. And the reason why it's specialised is it contains various other things which you'll talk about when you do your oral biology module, but suffice to say, you'll know obviously that this dorsal surface of your tongue, top of your tongue, is roughened to help with the process of mastication, and also we have different types of goblet cells that produce different types of mucus to aid with our taste function. So within the mouth, within the oral mucosa, we have masticatory mucosa that's keratinized, lining mucosa that's non-keratinized, and also specialised mucosa on the top of the tongue. But they are all mucous membranes. So the next membrane to talk about is a serous membrane. And a serous membrane secretes a really fluid, watery liquid. So it's not quite as moist and slippery as a mucous membrane. It's watery, like what you would get out the tap. And it's effectively a sac of loose connective tissue lined with a simple squamous epithelium. So rather than stratified like a mucous membrane, it is simple epithelium on the inside. So thinking about it in terms of like a fluid-filled balloon, the red around the outside of this image is the loose connective tissue, and then lining the inside of that is your simple squamous epithelium that's producing liquid that is filling this balloon or sac. The purpose of a serous membrane is to allow organs to move within their cavity without friction. So for example, if you think about the lungs, they lie within the rib cage. And obviously the lungs move, they go in, they get bigger and smaller as we breathe in and out. Now if they were to just rub up against the cavity in which they lie, they'd be rubbing up against the bone of the rib cage, and that's obviously likely to cause damage to the very delicate tissue of the lungs. So instead we have this serous membrane that sits between the lungs and the rib cage, and that's what you can see in the image below here. We have a lung on each side, and then we have a serous membrane all the way around each lung. And when the serous membrane is serving its function, it's known as the pleura. So you see it there, Pleura, pleura. Or plural if you're talking about it when it's in function. And you find the pleura in various places throughout the body. We have the pleura surrounding the lungs, We also have one surrounding the heart, which is obviously very important. The heart is moving all the time as it beats. It needs something to stop it being damaged. It's also within the vicinity of the lungs and the ribcage. So surrounding the heart, we have pleura known as a pericardium. So cardiac tissue, peri meaning surrounding, pericardium. And then we also have the peritoneum, which is a serous membrane or sac that lines the entirety of the abdominal cavity. And it separates the contents of the abdominal cavity, including all the intestines, liver, gallbladder, that type of thing. It separates that from things that might damage them, such as bone, the spinal column, and it also keeps them a bit more protective within our body. You would have to not only pierce the cutaneous membrane of the skin, but also go through the peritoneum, the serous membrane, to get to the abdominal cavity and its associated organs. So where we've got organs that need to move without friction is where you find the serous membrane. When they're in place, we've got a number of terms we use, and we will cover these more when we talk about the body systems, but just as an introduction, the side or the inside of the serous membrane, which surrounds the inside of the organ, that's what I'm trying to say there, is known as the visceral layer. And then the serous membrane that surrounds the outside of the cavity, so in this case the rib cage, is known as the parietal pleura. So visceral on the inside, parietal on the outside. And that's really everything we need to know about serous membranes at this stage. Like I said, as we go on to talk about the particular organs and the systems with which they work, you'll hear more about serous membranes. So the last type of membrane we need to talk about is synovial membranes. And synovial membranes are found in the cavities, so lining the cavities of movable bony joints. Classically, we're talking about the knee, the hip, the wrist, and the elbow. Now, this diagram we've got here is a basic synovial joint. It's not particularly depicting any one of them. We're just looking at two bones coming together. It's the basic structure of a synovial joint. And it serves a similar function to the synovial, to the serous membrane, in that it's there to reduce friction. But in a synovial membrane, it's there specifically to reduce friction between bony joints, as opposed to the serous, which was about organs moving. So it protects the joints and all the associated structures, so your ligaments and your tendons, by preventing friction during movement. Interestingly, a synovial membrane is actually not an epithelial membrane. It's entirely made from connective tissue. So it seems a bit of a silly place to talk about it, given we're talking about epithelium, but just to keep it all together. So it's a non-epithelial membrane. And it secretes a sort of sticky, oily type fluid. So in the same way as if you have in your car, you've got metal joints that come together and oil lies between them to stop the friction there. It's an oily type fluid that lies in a synovial membrane because it's such a solid piece of materials that come together. So again, a synovial membrane is a sac, and it lines the entirety of the joint, and it continues with the cartilage of the joint. So the cartilage comes round, and then the synovial membrane starts, and then it comes up and the cartilage starts again. So it's creating one sealed structure. And sometimes people have issues, when people have issues with joints, such as knees, knees in particular, and particularly people who've been athletes who've had a lot of hard impact on their knees, so classically long distance road runners. They can damage the joint to the extent where the synovial capsule created by the membrane becomes perforated, and then the synovial fluid leaks out. The joint becomes swollen, but in fact, actually inside the joint, the bones become closer together, and then you have friction issues because you've not got that membrane separate. So that's just really run through the 4 different types of membranes. If we go back to the list there, cutaneous being your skin, mucous membranes having a protective and propulsion function because it secretes a sort of moist, slippery material, and we find that in the mouth and lining the tracts in our body that require movement, so the GI tract, urinary tract, respiratory tract. Then we have a serous membrane, which is a sac of watery liquid, and that's found protecting organs to allow them to move within their cavity without friction. And then lastly, we've got synovial joints, which are between movable bony joints, and it creates a sac or a capsule of sort of oily material to stop friction there. So that's us covered membranes. We'll talk about it a lot more as we go on throughout the module.